Woohoo! We are live. This is Math 60 Intermediate Algebra, and I want to talk about the number E. First thing you're going to say is E is not a number, and I'm going to say, au contraire, E is a number. So there's a number between 2 and 3 that can be very useful in the study of exponential growth. It's known as, and this is a hard word to say, it looks like it should be pronounced Euler, if you're used to the English word ruler, but it's actually, I've been told, pronounced Euler. So Euler's number, which is known as E, and I will tell you there is some controversy about whether Euler's number is why it's called E or not, but I'm just going to go with it because that's what I was always taught. And E is this wonderful number. Notice it's about 2.7 and a little bit extra. And we have a definition, and unfortunately the definition, and I also have a galaxy, there's galaxy. Well, there you go. Well, there we go. Galaxy love E as well. Oh, this is awkward. Okay, come on. I love you. Yes, I know. Oh, somebody wants snacks. Oh, I'll get you a snack in just a little bit. Okay, let's try this again. E is a number that is non-terminating, non-repeating. So you guys know what that means. This is going to be an irrational number, which I mentioned down here. I did my whole report on E. This is very exciting. I know this is my oral report on E. You think oral reports aren't preparing you for anything? Well, they're preparing you to teach. Every day is an oral report. E is this thing called a limit. So that means what you do is you try a bunch of values as n gets bigger and bigger and bigger. So I would plug in n equals 10, n equals a million, n equals a billion, n equals a trillion. And I would look at what this was, 1 plus 1 over n to the nth power. This describes exponential growth. You can tell that's right there. That is an exponential function, but there's also something else going on, that this little fraction is getting smaller while the exponent gets bigger. And the really cool thing is the two of them work together and we end up with this number. So, and I wrote it, as n gets very large, this value gets closer and closer to the value of E. So that's why the limit as n, and we don't actually plug in infinity. We just say n is getting very large without bound. Okay. So what's special about E? What's the big deal? Well, it is irrational. That's why we named it E instead of having to write 2.71828, some other stuff. It's also transcendental, which is one of my favorite things. So basically, most numbers can be expressed as a solution to an equation. For example, if we were in class, I'd say, give me a number, and you might give me number 5. So the number 5 is a solution to 0, right? Because 5 squared minus 25 is 0. There you go. So we can write 5 right like that. In fact, I could have picked something similar. There are no algebraic equations using integers that actually have E as a solution. So E is like a superhero irrational. It's the most irrational. It's not the most rational. There are some other transcendental numbers, but it's one of the ones that we actually talk about a lot, which is very cool. So E is used to describe the growth of money, as in compound interest, which you study in business or in other fields, or populations, so people, bacteria, rabbits. It also appears in a few very famous equations, including this one. This one's mathematicians get all really excited about. This is known for some people as Euler's equation. I forget, there are a couple other names for it, but look at what we've done. E raised to the I pi, remember I, times pi, plus 1 equals 0. So why is this such a big deal? Well, this is like the grand unification theory of math, all in one equation. We've got E, we've got I. I is the imaginary constant. pi, pi, famous for circles and a lot of other things, plus 1. 1 and 0 are the foundational numbers for building the number system, right? You got to start with 0 and then go into 1, and then you can derive all the other numbers from the two of those. And here's the other cool thing. It has a plus, it has an equals, it has implicit multiplication, and it has exponentiation. Oof, I said it right the first time. That's very exciting. So that is like the best equation ever for mathematicians. We all get very excited about it. And E is a very important part of this. Now, to truly understand what's going on here, obviously there's some stuff, because you're all like, I have no idea if this is true. Well, if you take trigonometry, you will start to learn this. Trigonometry and calculus will bring you into the fold, and then you can be like, oh my gosh, this is amazing. So one thing I do want to point out, because a lot of people hear E and they're like, oh, E equals mc squared. That's a capital E. And yes, you're on the right track. That's physics. Physics is very close to math, except, math is better. But E is capital E. And this was Einstein's theorem, right? And it said that the energy represented in a quantity of matter is the energy equals the mass of that matter times the square of the speed of light, which that's pretty amazing and bonkers in its own right. But that is not the same E, different E completely. This E is a variable. RE is a constant. And so what I wanted to do is, and then after talking about like the universe and all these things, to talk about a calculator and squaring E seems it's kind of coming back to the planet in a sad way, but let's do it. Okay, so how do you get E squared on your calculator? Well, you're going to look in your calculator and you're going to see that there is a sum to log naturel, and a right log, which will give so no matter how far out you all three exponents